and what can you expect with the word artificial intelligence and machine learning. So I don't know, like you might have heard it quite a lot that data-driven artificial intelligence, machine learning, deep learning, and all of those areas of research have been a really hot topic since the last, I think like last 8 years. And today what I'm going to do is that I'm going to give you a little bit of an idea about what those terms mean and how can they affect you as a student and as a professional, or when you try to go into your professional life. So, I mean, as artificial intelligence becomes more of a topic, like a hot topic in the industry as well as in the academia. So as a student, you can expect that, I mean, most of the, even if you are doing electrical engineering, even if you are doing mechanical engineering or computer science, or even if you are doing medicine, then you can expect like this particular technology to be applied, to have projects that use this type of technology, and to have this technology providing value to that subfield. So, I mean, if you are in the university right now as a bachelor student, I'm pretty much sure that you might have heard about topics or projects that talk about artificial intelligence. You have like data-driven projects, and you have quite a lot of big projects and small projects that use this type of technology. And these kind of skills have suddenly become kind of like demanding when you go out and look for jobs. At least like there are jobs that ask you to have these kind of skills. And as a professional, it's more about, okay, you have this huge influx of data. You have data from internet, you have data from sensors, you have data from devices that are there in the pockets of humans. And what do you want to do with that data? So there are quite a lot of companies that use that data. For example, the company that I'm working upon, to give value to the customers. And then they would ask you, okay, how do you know how to handle this data, or do you know how to make use of this data? So as a professional, you can expect that there would be like jobs that kind of like ask you to have these kind of skills in the future, or maybe right now also. There are also new engineering practices. So you have like common software development rules, but now the software development rules have been merged with a little bit of machine learning or data-driven rules. So yeah, I mean, you can expect that even if you are working towards a software development degree or role, then maybe in the future you might be asked to develop software development principles which are in line with machine learning principles. And these are all the things that I might discuss in a little while. But yeah, this is basically just to get you started as to how artificial intelligence affects you as a student and as a professional. So yeah, and now the major question. So I mean, how to get started with this type of technology if it affects you? So I mean, first you have to understand if you really want to do this, or if you really want to get into artificial intelligence and machine learning, because the topic is pretty much broad and there are so many subtopics that it's easier to get lost into this kind of like this ocean of information, I would rather say. So but due to the internet, it's thankfully there is so much of material out there that you can easily find material without paying for it, and you can even get really good at it, I would rather say. So some prerequisites. I mean, like, I haven't really discussed what machine learning and AI is, but I think like there are quite a lot of questions that have been sent to me by a boss. So I think like when we go through those questions, then we might get a little bit of a more idea. But yeah, let me just get started with like how to start with machine learning and AI. So, and what type of prerequisites you need to have if you want to get started with machine learning and AI in general. So, I mean, these are some of the prerequisites that everybody, I think, who has done at least the first year of engineering, then you have that. For example, basics of linear algebra, such as matrices and matrix calculus. I think, yeah, everybody does engineering mathematics, even though like it's a little bit different in Jamia, I understand, but it's still like you get a little bit of an idea about what matrices and what linear algebra is. If you take a look at the book, then you might be able to get a little bit of an idea. And you should know some level of probability. I think like even if you have done probability from your 12th standard, that should be pretty much enough. A little bit of a Bayes theorem and all of that kind of things, you can easily get a grasp upon. And knowledge of a programming language would help you get going with the projects. So, I mean, even before you get started, okay, I want to do this machine learning thing, or I want to do this artificial intelligence thing, just take a look if you have these kind of prerequisites with yourself. If don't, then try to get them, like trying to get at least some kind of an idea about a programming language. Try to get some uh, basics of linear algebra. For example, what is a matrix multiplication? How do you multiply two matrices? How do you take a derivative of matrices? So to get these concepts done with, so that it's a little bit easier. I mean, there are quite a lot of courses. When you do them, then they teach you how to do all of this kind of stuff, or they don't require this prerequisites. But if you really seriously want to pursue this particular field, then I think it's a little bit of a good idea to get acquainted with all of these kind of topics. What not to do. So this is kind of like important. So don't do 1,000 different courses. There are so many courses online that I think, like, if you start doing all of them, then yeah, you might even get a PhD. So, but don't do 1,000 different courses. If, I mean, since you guys are engineering students, for you, I think like the main thing is to build stuff, to build products, to build projects that can add value to, yeah, anything. I mean, for example, that can add value to your university, that can add value to your resume, that can add value to another company or something like that. So, I mean, until unless you really want to study a topic, for example, I really want to study the math behind artificial intelligence in detail. I would really want to study the fuzzy mathematics and stuff like that. So for that, I think, yeah, I mean, when you learn it, then you get a little bit of an idea about it, but don't do 1,000 different courses. Just do one course, do it diligently, complete it. And when you have the basic idea, then try to build something. And don't pursue overly complex projects. So I don't know like how many of you are in your final year of engineering, especially for computer science final year of engineering. If you pursue a overly complex project that requires a lot of data and that requires a lot of compute, so yeah, I mean, it becomes a little bit problematic. You don't end up completing your projects. And I think, I don't know about the job situation in India, like if they really ask you about these projects, but I think your thesis is something that you should really be focused about, that you should really work upon, because this forms the basis of your bachelor's. Everybody, when you go abroad, at least everybody is going to ask you, okay, what thesis did you do? Why did you do that? And how did you do that? So don't pursue overly complex projects. But yeah, this is just basically what not to do. So it's like a small presentation. As I told you that I think when we go through the questions, then I will uh, describe into detail about machine learning and all of that kind of stuff. So, but yeah, now some good links. I think like there are quite a lot of great courses, as I said, online. But one of the courses that I think is really relevant, and this is something that I also did, was the deep learning AI, deep learning specialization. I think you can find all of the videos online also on YouTube or something like that. But I think it's a really nice course. If you do that, I think you don't need to do quite a lot of other things. You have the basic knowledge, you know the math at least behind machine learning to some extent, and you know how to program stuff to some extent. And then you can basically, for example, if you do 5 different topics and you find, okay, I like natural language processing the most, then you can go on and develop into that subfield, because that would be a nice idea to get like a basic idea of what different types of techniques and technologies are there in machine learning and deep learning or artificial intelligence in general, and then try to pick up something. YouTube has got a lot of good resources. I think if you find, and I think like there are quite a lot of, there is one channel which is called Yannick Culture. If you already have some idea about machine learning and deep learning, then you can take a look at his videos. He discusses the papers that basically make the foundation of machine learning and deep learning. And this is not limited to this particular repository, but you can find a lot of open source. I mean, the open source is filled with projects, and I don't even think like you need to write any more code. You can find all of the code in some kind of open source repository, and you can build up products or projects with using that particular code. So that's a nice thing. I mean, until unless you know how algorithms work and what do you need for those algorithms, I think you can find implementations online pretty easily. Blogs are a great source of learning. And Kaggle, I think like there are questions regarding Kaggle also. So yeah, I mean, Kaggle helps you get data, compute, and you can participate in competitions, try to get like take a look at how other people work on these kind of technologies, use these kind of technologies and stuff like that. So yeah, that's just a small presentation. I wouldn't take too much time with that. I think if you guys need anything important from that presentation, then I think the organizations can share that. And for me, I mean, I'm pretty much just active on LinkedIn and email. So if you have any questions, you can reach out to me. I mean, I might take a little bit more time to reply. I'm pretty much free on the weekends, but not on the weekdays. But yeah, I will surely reply. I mean, it's not a problem. Don't get discouraged if you don't see my reply in 2 or 3 days. So yeah. So that's it. So I think like then we can take the questions, because I see that the questions are something that are really interesting, more interesting than my presentation.
Thank you so much, Najeeb. So with that, we
Thank
will
you.
go ahead and take some times for the question. Now I request Abbas to take over for the question answer session.
Thank you, Sarah, and thank you, Mr. Najeeb, for your great presentation. So let's begin with the series of questions that I have collected, which are generally the questions that usually a lot of people have initially. So I've collected a few of them, and you have the list as well.
Mhm.
So let's start with the first one. What is machine learning? Like, if nobody has any
Mhm.
clue about it, how would you describe what is machine learning to that person?
Okay, so I mean, machine learning, it's kind of like you typically create mathematical models. I mean, you create, for example, some kind of an algorithm that uses some kind of data, finds some patterns into it, and then tries to predict for future values or for some values in between, try to interpolate or extrapolate values based upon this particular data that you have provided. So, for example, if you I give you I mean, there is a classic example. For example, if I give you the prices of houses in a certain locality, and I tell you that okay, the houses have four bathrooms, they have like five what do you call it, rooms and stuff like that, and you have the list of houses, and you have different features for those houses, and you have the prices for those houses. So what are you going to do is that you're going to create a mathematical model that's going to take a look at all of those houses and try to see, okay, if a house has, let's say, 5 rooms, then its price should be maybe $500,000 or something like that. So machine learning is basically just doing that. It's trying to find patterns in the data, and using those patterns in the data, it's trying to extrapolate or interpolate or like predict into the future or something like that.
Okay, that's interesting. So, like, I have a like this is one of the questions that I had initially as well before I started doing machine learning. Like, how can one decide whether ML is for them? Like, are there some kind of inclinations that you need to have? Whether you need to be a lot of analytical kind of a person, mathematical, you need to be very good with mathematics. Like,
Mhm.
how does one decide whether a career in ML would be quite fruitful for them? Do you have any pointers on that?
I think like for machine learning, normally everybody starts to like machine learning in the beginning. I think, I mean, because it's something that you can see. I mean, especially like when you get started with something like an image based deep learning or something like that, then you can see quite a lot of stuff. So everybody starts to like it in the beginning. I think like when you the most important thing about machine learning in general is that you should like to you should know like the math. I think like that's really important. Math comes at a really basic level. So especially like I think you should have a good understanding of calculus. I think for calculus it becomes like it makes the ground for the machine learning. So normally if somebody, I think like they like calculus, they would instantly like machine learning. I don't know. I think like I used to like calculus, that's why I like machine learning. But it's more about in comparison to conventional what you call it software products, machine learning products, they instantly give you some kind of what you call it they instantly solve some kind of complex problem that it's really difficult to solve with common like software engineering tools. So I think like yeah, if you are into that particular domain that you want to use data to solve some kind of complex problems, and your interest lies in doing experiments and then using those experiments to basically develop something, some kind of product or some kind of solution, then I think yeah, I mean data and calculus, I think for me are the two most important things that can help you like machine learning more.
Okay, okay.
Yeah.
So I mean, there are usually two philosophies of how to like tackle mathematics for ML. There's the bottom-up approach, like where you just go ahead and just learn all the mathematics that you need for ML,
Mhm.
and then you begin learning the algorithms. Or there's the top-down approach that you just learn the algorithms, you learn how to code and do scikit-learn or all those kind of libraries, and then you dive later into the mathematics. So, which
Mhm.
approach do you prefer?
I think I prefer the top-down approach because I mean the math in itself is like there is quite a lot of math that you don't actually need on a daily basis, so you tend to like forget. So for example, if I spend a lot of time in yeah, learning about a lot of like let's say Bayesian mathematics, and I don't end up using it Bayesian mathematics, then I mean, that I don't think so. It's like a fruitful time. I mean, you should have a basic understanding of what everything is, but to get like a really deep idea of every math behind the machine learning, not machine learning, but every math that is out there, I don't think so. It's a nice idea. So for me, like what I would do is that I would have like basic understanding of linear algebra. I would have some basic understanding of what probability is, what do we mean by Bayes theorem, and all of these kind of stuff, and then I would just start working on some algorithm. And for example, if in an algorithm I come across some new kind of transformation that I need to look upon, then it's pretty easier to understand because you know the basics, all of the things, all of those transformations, all of that kind of stuff is basically based upon those basic things like matrix multiplication or matrix calculus. So you can easily build that up and use that knowledge for your whatever you are doing. I think like for me personally, top-down approach is a nice idea, although I would rather stress that you should know the basics well.
Okay. So like you learned ML yourself as well. So like in your time, how did you go about learning ML? Like what were the resources you used and what actually got you interested in doing ML in the first place? I think you already elaborated on that, but like if you can just share your journey of how you learned ML and how you ended up doing a master's as well in the field.
Mm-hmm. Uh-huh. So, I mean, I started off, I think one of my seniors basically did a session or something like that. And he told, I
Okay.
actually was in my second year or maybe like second, third, no, I was in second year. I remember that. And at that point of time, I didn't know like what to do. I mean, I was just doing my studies. So apart from that, I just used to hang in the cafeteria, I guess,
Did
most of
you
the time.
did you do any web
Uh,
development or anything by that point?
I I did some web development using
Okay.
Django,
Okay.
and I mean, but after that, like I didn't really find myself into it. So that's why I also did competitive programming. I tried hard quite a lot, but I wasn't able to do anything about it, and this
Okay.
still haunts me. But yeah, I think like machine learning. I mean, this is something that was not the fab back then. Like nobody, not many people I saw that they were doing. There were like classic machine learning stuff happening in Jamia a little bit, but normally the students wouldn't do that. The students basically would do some either development stuff, or they would rather just do competitive coding because that was kind of helpful for the jobs. I mean, I started out because just of one of the seniors, and then I took up one course. And during, I think, my winter vacations, I did that course, and I really liked the subject, so
What was
I
the
kept
course?
doing that. I think it was the first Andrew Ng course, the core
Okay.
machine learning course,
The Stanford machine learning
and
course.
yeah, that was really nice, and that was, I think, like one of the first courses that I completed. And I think like that was kind of enough. Then I did a little bit of Python stuff for machine learning, and after that, like it was more like, okay, what should I do? And then I started doing a little bit of Kaggle. I had a couple of friends who also used to do the same, so it was a little bit easier. This is something that we would do usually in our free time, or this is something that we would do during the vacations because everybody wanted to get a research paper out and all of those kind of stuff. So we would say, okay, there are teachers who are doing that. Let's just go to them and ask them if they have any projects, or do our own projects, use the infrastructure that is there at the university somehow. So that kind of like developed. It was not more like a structured, I would rather say, approach towards machine learning. It was more like, okay, this is something that I like to do, and this is something that I would like to do. Yeah, it's simple as that.
Okay. So you mentioned Kaggle in there as well. Like, so what is Kaggle? Like, if you can just give an introduction, what is Kaggle, and like, why is it important for doing ML, and how important is it?
So I think like Kaggle gives you a really good start. I mean, you have the data there that is really nicely parsed. So you don't need to do any kind of really elaborate data cleaning procedures or something like that. So what you could do is that you could just take the data, and then, for example, if you have just completed a course, for example, like the Andrew NG course that told you how to use neural networks or how to use some kind of fancy machine learning or deep learning algorithm, and you have used it on one of the data sets that were there with the course, but now you want to try to use it on some other kind of domain. Maybe you want to do it on a medical data set. Maybe you want to do it on a, let's say, sound data set or something like that. Then, I mean, Kaggle helps you get the, I mean, at earlier points of time, I remember that Kaggle was just for competitions, but now you can get the data on Kaggle. You can you can use the compute on Kaggle and basically put up your code on Kaggle so that other people can look at, you can look at other people's code. How do they approach a problem, and how do you approach a problem? And I think that helps you learn quite a lot. So Kaggle is kind of like, for me, it's just a platform where you can get the data or participate in competitions. Yeah, competitions are one of the most important parts of Kaggle. So you have like these big competitions. I think they also have money inside them, but it's really hard to get on the top because there are so many competitors. But you can participate in those competitions, you get the data, then you can try to run up some models and then put your predictions on their test set, and then they will basically score you based on your performance, and then you will get some standing in a leaderboard or something like that. So that's also nice. But for me, Kaggle was more like a resource rather than a competition platform.
Okay, so like, are the competitive ranks helpful, like for, let's say, applying for a job or an internship on your resume,
I think
getting good
Kaggle,
competitive ranks? Or like, should someone pursue it as just a way to practice, or like should like go and like try to compete and get better at competitions? What would you think is the right way to go about it?
so I think like personally, I think it's a little bit challenging to devote yourself completely to competitions, because there are actually people who just do that. They there are people who are like freelance data scientists or something like that, and they are actively like preparing for those competitions, actively like pursuing those competitions. So if you really expect that you're going to be in the top 10, then I think that would require a lot of time from your side. And I don't think so like it's really I mean, I don't think so it's a good idea to spend all your time into that area. I mean, in the end you will end up getting one project out, and then you will get like, okay, maybe let's say 10th or 11th position, but that's really nice. If you can get that, then it's really nice. But I think like for me, and in my opinion, if I think it's more like, okay, you should participate in the competition so that you get experience, and also like you can show it on the resume. People look at your resume and look at all of these different kinds of projects that you have taken part in. I think if you are applying for a machine learning job, then it becomes important to have projects, because that shows that, yeah, you have worked upon these kind of technologies, you have worked upon how to handle data and stuff like that.
Okay, so like you would talk getting into the job opportunities and the career prospects. Like, so like, what are the possible job opportunities after BTech in ML? Or do you think
Okay.
pursuing higher studies is actually necessary to like break into machine learning? There's someone
Okay.
else sharing the screen.
I think yeah, you can disable the sharing of the screen.
Yeah,
I think I can see myself only in that. But anyways, for
yeah.
I mean, job opportunities, I think after BTech, it's gonna be I mean, it depends on where you are seeking the jobs for. Are you seeking the jobs for big companies? For example, if you want to go for like Amazon as a machine learning engineer, or as like an applied scientist, then I think after BTech it becomes a little bit difficult, because I mean, they would ask you to have some kind of research experience, or you would be competing alongside people with PhDs and people with masters. So I think it becomes a little bit difficult. So for startups, I think like the story is a little bit different. I think you can approach them if you have decent projects, if you have decent, what you call it, experience with machine learning during a bachelor's and during your thesis, then I think that could be taken into account. But one thing that I would like to stress upon is that, I mean, even I mean, as a master's student, when I was looking for jobs, then even if you are applying for a machine learning job, they would definitely ask you software engineering questions. You
Okay.
can't run away from that. For I mean, you can't run away from like breadth first search, depth first search.
Okay.
You can't run away from like solving of the dynamic programming problems. because I mean, if you apply for a machine learning engineer job, then it adds like a new added layer of questions for you. So you will have to solve questions for the software engineering, but then you will also have an added interview where they will ask you about machine learning. So it's kind of like a double whammy. So yeah,
So there's no way to like escape from DSA. Yeah, so we'll have to
there
do
is no.
DSA.
Yeah, I mean, I think I'm not saying like to completely devote yourself to it, but it's more like you should have an idea about how to solve problems. They would ask you, they would give you, like, for example, I interviewed and they gave me a problem of here and there, like the normal DSA problems. And I think like one of the ways that they give you these problems is that they want to check your problem solving skills. But
Okay.
the other way around is that there is so much of competition out there. Like
Okay.
everybody wants to apply for machine learning. So what they do is that they basically add this layer of selection using
Okay.
those DSA and stuff.
Okay. So you probably spend time doing DSA as well. So like, if you wanted to give suggestion to the presently second year and third year students, like how should they manage like doing DSA and doing machine learning?
So I think like I would basically say that first get a hold of the basic concepts. Like you should know what the basic principles of data structures and algorithms is. Even like the stuff that you study in the university. For example, you should know what trees are, or you should know what a linked list is. You should know like what are the heaps or stuff like that. So all of the basic data structure and algorithm stuff you should have knowledge about. Now come the questions. Like, should you do questions? Should you do problems? Then I think like if you can do it like side by side in your daily life for the second and the third and the fourth year, then it's going to be easier when you start applying for interviews, because you already would have not like all of that kind of experience, or you already would be comfortable with the questions. The second thing is that you get the basic idea of data structure and algorithms. You do some questions, then you do like machine learning stuff. You do it in your thesis, you do it in your major or minor project, or anything like that. You do the project, and when you know that your interviews will start, then you should start spending more time with data structures and algorithms, because in interviews, first you will basically qualify the data structures and algorithms round, then you will be able to answer or show off your machine learning skills. And the machine learning skills, I think they remain in your mind a lot longer, because they are pretty much like math or theory. But data structures and algorithm skills, they come when you solve questions. So I think like as soon as you start solving questions, um, before your interviews, as earlier as you start solving questions before your interviews, I think it would be easier for you to go for like these kind of roles. The other thing is there, like the big companies usually normally, for example, if you go about like Amazon or Facebook or something, Microsoft or something like that, they don't generally hire masters, or they don't generally hire bachelor's and master students for the role of, like, they don't even have machine learning engineer roles. They have either research engineer roles, or they have like data scientist roles, or they have like a research scientist role. So all of these scientist role, especially like research scientist role, they are strictly reserved for PhDs. So you need to have a PhD because you're going to go for a scientist role. For a research engineer role, what they do is that they either hire directly for like these research engineers, and you are a bachelor student, you can directly apply for that. Or maybe what people do is that, I think there was one guy in my when I was there in bachelor's in Jamia, he applied for a software engineer role in Microsoft. He got into it, and then he changed as a research engineer. So normally what these companies are doing is that they want engineers to work on these kind of solutions, these kind of machine learning problems, and they have the scientists who are actively working on developing those algorithms. So they take those scientists and they say, okay, let's bring up like software engineers, and then use them as a research engineer. So I mean, there is also a possibility that you go for software engineer role in these big companies, and then you take up a department when an opportunity opens up as a research engineer or something like that.
So that is interesting. Like I did not know like you can like become a software engineer and then get into machine learning in the same company. So that's
I
an
think it's
interesting
possible.
insight.
It's possible. Yeah, it's
Okay.
possible. I mean, like it's possible. I wouldn't say that you can expect like 100% turnover rate that you go for like a software engineer, become a machine learning engineer. If you are really interested in machine learning, and if you think that this is something that you want to do, then maybe you should just look for machine learning engineer roles, or maybe you should look for some opportunities that can help you land those machine learning engineer roles.
Okay. So are like we've talked about research. Like, is are research publications necessary to land a job in machine learning, as even as a machine learning engineer, or like do only these scientists, machine learning scientists, would require publications?
Mhm. So for scientists, I think like it's really important.
Yeah,
I
that's
mean, if you are applying for a research scientist role, then you need to have some publications. They would even ask you that. But for an engineer roles, I think it depends on, if you don't have projects, then you should have publications. But if you don't have publications, then you can have strong projects. For example, you could have built something nice, built a service or something, or you could have like contributed to some open source project or something like that, that can give you an edge over the publications. Having publications is a nice idea. It's really, right now I think it has become kind of like a norm. Mostly people tend to have publications when they apply for machine learning engineer roles. But I think they are not like a strict line. They are not a strict requirement, I would rather say. But yeah, if I mean, that also depends on where you are, what kind of research papers you have. I mean, if you have a research paper in like a really what do you call it, small journal or small what do you call it, conference, and if you apply for big companies, let's say Amazon or something like that, then I don't think so they would have like pay that much of attention to it. I mean, if you have like papers in really nice conferences, then yeah, they might pay attention to it. So it also depends. But for engineer roles, I don't think so. That's a strict requirement. If you can get them, then it's nice, but you can also cover up all of those things with your projects.
okay. So let's talk about projects. Like, what kind of machine learning projects have you worked on during your undergrad, and let's say that helped you possibly land your job at the startup? And like, how would you
Uh-huh.
advise someone who is looking to them like, when should they start doing projects? Like, they've done a course and then maybe learn more mathematics and theory, and then maybe start doing projects. Like, when should they start making machine learning projects?
I think like when you have done a course and you have a basic understanding, then you can start working on projects. You can start first building up small projects of your own, and then when you get a little bit of confidence on how to write code, how to write better code, then you can maybe start contributing to open source if you can find some open source and if you find it easier. Otherwise, what you could do is that you could just make your projects a little bit bigger. Use software engineering skills in your projects. Try to have like bigger projects that uses all of these kind of fancy inheritance and all of that kind of stuff. So that for example, when you show up a project and you tell your interviewer that this is a project that I made that uses these kind of principles, software engineering principles or machine learning principles, and I think it would be a really good impact. So I think you can start right after you have done some courses and you know some coding. Now you are comfortable with the coding, because when you do projects, then you get more comfortable with coding in general, and you know a lot more about how to code stuff, how to look for the stuff online. And yeah, I think like then you should use your major and minor project as time to make bigger projects, because I think that would be a really nice idea
Can you
to use
elaborate
that.
on what are major and minor projects? Because a lot of the people
I
are in
think like
India, so they're not much familiar with what are.
okay. Sorry for that. Sorry for that. But yeah, major and minor projects. I think like when you go in your final year, then you have a minor project which takes up your seventh semester, and then you have like a major project which forms the major chunk of your credit for the last semester, and you actually get a lot of time to work on those projects. So yeah, I mean, like in the last semester, you also have to look for jobs and stuff like that. So I wouldn't say that's a lot of time, but I mean, these are kind of like your allocated time in your college. So try to use that time to make projects, make like good projects that you can show off when you sit for an interview or something like that. I think like those two projects are good. And then in your third year, in your spare time, maybe you could do some kind of project, or maybe during vacations you can land an internship and do some work there. So all of these kind of stuff will, I think, projects are, I would rather say that they are really important. And as you said that, like when I was looking for jobs after did my master's, I had a couple of projects, but I mean, yeah, I had to, most of the people would just start off asking by, okay, what did you do in your master thesis? What was your master thesis
Okay.
like? And so I don't know about like, when I applied for jobs in India, like when I sat for the interviews in India, then I think it was more like the standard interview procedure. Okay, Najeeb, come do solve some problem, solve this puzzle or stuff like that. But there might be like some people who there are some that depends on company to company. There are some companies who ask your project, so it's a nice idea to have your at least major and minor project that is in the 7th and 8th semester to spend some time on that to make it a little bit better.
So this is a must for all students, like to complete their BTech, right? They must.
Yeah, I think like this is I don't know like if the pattern has changed in India. I mean like in Jamia, but I think it's going to be like that. And you have to do that in
So
the seventh
can
and eighth semester.
so like this comes to my next question. Like, let's say someone is in mechanical engineering branch. So like, will their BTech project can be in machine learning, or is that possible?
I mean, I think I don't know. That depends upon the of your professor, obviously. I
Okay.
don't know about like how good the professors are. If you tell them, okay, I want to do this kind of project, but you can certainly find projects in mechanical engineering that use this data driven. I mean, obviously, you need to have some programming background for that
Mhm.
because I mean, if you are using data driven kind of like decision making softwares or something like that for mechanical engineering products, then you should have some programming experience. But I think like it's possible to do that. Like I've seen quite a lot of people in TUM specifically, even though they were like mechanical engineers, they would use this technology. So for non-CS people, I mean non-CS and non EC people, I would rather say that you try to use machine learning as a tool in your own studies. So like for example, if you are doing some kind of circuit analysis and then you find, okay, this is something that I can do better with is some historical data, and I have historical data available for it online, then yeah, make that as a project and use that. So if you're real, I mean, like, don't try to like throw away your all of your education, all of your electrical or mechanical engineering education or your civil engineering, but try to incorporate, use this as a tool. I think like that's a really nice idea for all of the other branches.
Okay, that's very interesting. So like branch doesn't isn't shouldn't be a barrier for you to, let's say, pursue a career in machine learning.
No, I mean like for specifically for this is for something that I really like about machine learning or data driven what you call it modeling, that it's not limited by branches. Even if you are even if you are doing medicine, or even if you I've seen like when I was doing my thesis at the university, I would see quite a lot of doctors like do this or
Okay.
help us with the projects. So I mean, they tend to use this as a tool. So try to, if you have some kind of computer like programming background, and if you have learned a little bit about machine learning, which I think most of the people tend to do, then try to use it in your own domain. I think that would be a little bit beneficial. And when you sit for jobs, then you could, even if you sit for like computer job, then you could say, okay, I'm a mechanical engineer, and see how I used this particular technology in my area of field. And I think this would be a really nice idea.
Can you elaborate what your master's thesis was on? And like when did
Okay.
you start? Okay, let's just answer this. Like when, what was your master's thesis about?
My master thesis was about, and I mean, like the name of the topic is a little bit complex. It's like longitudinal CT scan analysis,
Okay.
but it's more like, so what happened is that we have the hospital, what university hospital, and after Corona started, there were like patients coming in the university hospital. So, and those patients were getting CT scans. So what the department that I was doing my master thesis at decided is that, okay, if we have a patient who has taken two CT scans at two different time points and he's COVID positive, then can we take a look at those CT scans and try to find out how much of the disease has progressed from time point 0 to time point 1. So this is kind of like longitudinal analysis of the CT scan. So you take two CT scans of the same patient and then you try to find out, yeah, different kind of parameters. How much has the disease progressed? How long the patient is expected to stay at the hospital? So my task was to basically build kind of like a model to that can solve this problem to some extent. Like we had really less amount of data, so I wouldn't say that it was a really nice project, but at least like we were able to get into some kind of we were able to create some kind of model and show some kind of results based upon that.
Okay. I have a question. Like, let's say like you can start with learning traditional machine learning algorithms like SVMs and random forest, or maybe you can directly start with deep learning. So which is the right way to go about it?
I think like That depends. Normally, people, the deep learning and machine learning, like earlier, it was not that much divided because the development of neural networks is still in the research phase. But now I've seen that deep learning and machine learning, they have actually divided themselves up, and most of the people, they tend to do deep learning. So I think like you can take a look at some basic machine learning concepts. You should know what a linear regression and logistic regression and all of these kind of stuff is, because they make the basic of data driven modeling. And after that, like, you don't need to go into the details of, for example, how support vector machines or all of those kind of traditional machine learning algorithms work. You should have a little bit of a basic idea about what those because most of the math is actually derived from that. So you could have some basic idea about basic machine learning stuff. For example, what is linear regression, what is logistic regression, what is stochastic gradient descent, and all of that kind of stuff. And then after you have some basic idea, then you can focus on deep learning. And when you focus on deep learning, then you mostly focus upon, for example, neural networks or their different architectures or stuff like that. Or maybe like when you are doing, and then you like, for example, recurrent neural networks, then you could do something like, yeah, natural language processing or something like that. So I'd rather say get the basics, get the basic idea about little bit of machine learning, traditional machine learning. Because if you go, especially for interviews, when you go for like deep learning interviews, then they can even ask you, oh, what is a support vector machine? Oh, you know a lot about convolutional neural networks, but you don't know about support vector machines,
Okay.
and you call yourself a machine learning engineer. Okay, man, it's gonna
So we should
be
have your like we should have your basis clear, but like let's say initially we can start with deep learning and then maybe later on cover all those traditional algorithms as well. So that's
yeah.
the
I
one way.
mean, it depends upon you mostly. Like, I think like you will forget. I mean, when you start working on deep learning, then you'll forget how SVMs work. I don't know how SVMs work, but at least I know like what they do. So
Okay.
this is something that you can have a little bit of an idea of.
Okay. So let's go to the next question. Is it better to explore a lot of fields during your undergrad, or like just if you find one field, just choose to master it? Which
Mhm.
which is
So
what is more better?
are you asking me this in with respect to the CS branch, or is it like in general any branch?
Like I would say let's restrict it to like if someone wants to explore the CS field as well, like web
Uh-huh,
development
uh-huh,
or cloud and anything
uh-huh.
of that sorts. Should they explore all of those
Yeah.
stuff, or like if they found one, just do it, master it only?
Hmm.
What's the
So I
right?
think like you should know the basics of your bachelor's education well. So
Okay.
I think like, for example, because this is something that people might ask you even later in your life. So for example, you should know about those data structures algorithm. You should know a little bit about how operating systems or database management system works. All of those, you should at least have an idea. It's not like if, for example, somebody asks you, okay, what is a relational database management system, or what are the software engineering principles, then you shouldn't be blank. Unfortunately, I have been blank in
Okay.
some of the interviews. Like, he asked me, okay, this is something that you studied in bachelor's, right? I was like, I studied, but I don't have any idea now. I might, I mean, so basically, yeah, so you should have whatever is there in your course, try to have a little bit of, yeah, try to learn it at least to some extent. And then you can find something that you really like and develop on, master that. So for example, and by mastering, I mean, you can have your projects in that. So when you create your resume, then you know the basics of your bachelor education. I'm not saying that you should actually know by heart what a semaphore is, or what is this message passing and all of that kind of stuff. But that's not required. But after having your bachelor's education, or like at least some core concepts, you can then pick up a area that you really like and develop yourself in that. For example, I like contributing to open source. Then I could,
Okay.
yeah, have like 5 6 contributions, major contributions in the open source that I spend most of my time in. If I like machine learning, then I could have like 5 6 projects where I went out, collected data, created my own machine learning models, and then basically made some baselines and published them online or something in a blog or something. Yeah, one thing that I would really like, I mean, I think it's a little bit challenging. It's now also challenging for me, is that you should always complete your projects. Try to like complete your projects. And
Okay.
I mean, like, I did a lot of projects which I started and then I left in between, and I think it was a waste of time, because
Okay.
if you don't complete your project, then you can't really tell anyone like whether you did that, because then if they get interested, then they ask you, okay, do you have something documentation about that? Do you have a repository? And if you say no, I don't have a repository, then they think that you are fluke, like you are just making up projects or something like that.
Okay.
So always try to complete up your projects, put your projects online, just to, because in the interview you have to sell yourself anyways. So yeah, so I think like that's
Okay.
important. That's a good idea to have.
So let's move on to the next question. How important is reading research papers in machine learning? And any tips on when should we get started with it, or if we should get started with reading research papers?
Mhm, mhm. So before you read up research papers, you should have the again the basic machine learning or deep learning concepts. For example, if I want to read a deep learning based paper about some new neural network, that architecture that came up, then they will use quite a lot of terminology that you should already have idea about. For example, you should know what backpropagation is. You should know like what for example, you should know what gradient descent it was, what gradients are and stuff like that. So I think like if you do any one of those courses, then you get a pretty decent idea. And then you could start reading up papers. At first, you wouldn't understand anything. I think everything will go above your head. And that should be the case. If you are understanding everything, then it's really nice. But then you can read up, then you can start reading like a couple of more papers. Don't hold yourself back. It's going to take some time. It's kind of like a steep learning curve. So when you start reading the papers, then you don't understand anything. But after that, because when you read papers, then you go back, okay, I don't understand this part, then it gets reinforced in your brain. And then when you read that same thing again in a different research paper, then you know, okay, I understood that again. So I think it would be a nice idea to read research paper on the same theme. So for example, if I like reading research papers about neural network architectures, then I could basically find 5 to 6 papers of neural network architectures, read one by one all of them because I am interested, and then I would be able to make those connections, and then it would be easier to read the fifth paper than it was to read the first paper. And that's why, I mean, it's not a good idea. I think it would even be a little bit difficult if you find a paper in the wild that doesn't have any relationship with neural networks, and you really like neural networks, and then you start reading them. For example, if there is a paper that uses game theory for neural networks or something like that, I mean, yeah, but it's going to be difficult because you don't know game theory. So don't touch those papers. Touch those papers whom you already have some theoretical background of. So I think it would be, but you can start reading them. I think like in your final year. I think in your final year you will read research papers, or even in your third year. I think in final year you will read research papers for your projects, major and minor project, as I said, which makes your thesis. And I think, yeah, for that you might need to read. So yeah, I think you can start reading them. I mean, they're not super important, I would rather say. I mean,
Okay.
it's not like you always need to read research papers. For example, there is a link about Yannick Kilcher. He's a
Mhm.
guy who makes these YouTube videos about these nice papers that come online. You can just follow him. You can get an idea. So
Yeah.
you don't want to read like 10 papers, 10 like pages of paper, so you can watch like a 20-minute video and get the same idea.
Yeah. The summaries are pretty great on his channel, so they are very helpful.
Yeah,
Okay.
it's really nice. It's really nice.
Yeah. Okay. So let's get on to the next question. Do certifications like this course certifications actually help in getting jobs? Like on their resume, having a certificate like said the deep learning.ai certificate or the machine learning Coursera certificate by Andrew Ng, do they help, or like just doing projects uh, will help?
uh, I think like I would rather say not put your certification on the resume. I mean,
Just don't
don't
put
say
it.
that I did this, I did this, because was
Okay.
working at a lab in TUM. And the professor, he's like a pretty nice and famous professor, and he tweeted that I don't like when people put these certifications
Oh, okay.
for their PhD qualifications. Like when they're applying for a PhD or a master's, then they send out their resume. And I mean, if you have these okay, I completed the certification by Andrew Ng TensorFlow, blah, blah, blah. Then he says that I don't like it because I see that mostly people who write this, they don't know anything.
Okay.
So yeah, I mean, it's a
That's
nice idea
interesting.
not to put it. I mean, don't put it in your, you can put it in your LinkedIn. I mean,
Okay.
because
Yeah.
in LinkedIn, you can put also like the certificate. Don't, I mean, in bachelor's you could, but don't put it after your master's. because after
Okay.
your masters, I mean, in bachelor's, I think you could. Uh, I mean, yeah, I think in bachelor's you can technically, but normally I think like people, since everybody starts to have these certificates, so people
Okay.
start to think, okay, everybody who has the certificates, they tend to think like, yeah, they tend to think, okay, this guy does have a certificate, but he doesn't know about machine learning. So that means this certificate could have gotten like by any means. So
Yeah.
that means it's not, yeah, I think it's a good idea to put projects. Projects are really important. Projects are nice. You should give a nice headline and a nice description to your project so that the person who reads it knows, okay, yeah, you did something, you contributed something in this.
So like buying courses to get the certificate is not that necessary. Just getting the knowledge and
Not a,
building projects is much more better. Okay.
exactly. If you can explain your project, then I think in the interview will be a interviewer or anybody like your PhD interviewer, if you are applying for a PhD or your master's interviewer, they would be happy about it if you can explain it.
Okay. So there's opportunities for machine learning in India and abroad. Like, can you elaborate on the differences on in the opportunities?
I don't know that much about the opportunities in India, to be honest.
Okay.
In abroad, I can only talk about Germany. Like in especially in Germany, there are quite a lot of opportunities, but it depends. Like mostly people here, they have some kind of prior experience in software engineering. So normally companies, they would ask you to have some kind of experience, even if you are a startup or something like that. Otherwise, you could basically do some kind of internship at the company and then converted it to a full time. That's what I did. I like interned for like 4 months and then I converted that to a full time, even at a startup.
Okay.
So I mean, the opportunities are there. I can't really comment on the Indian opportunities, but as I see that there are quite a lot of startups in Bangalore. So if you have quite a lot of startups and most of the startups tend to use data, so that's why you have opportunities related to data engineer or data scientist or machine learning engineer, then I think, yeah, you might be able to find that. In abroad, in especially in Germany, there are opportunities, but they tend to give experience a little bit of a higher, what you call it, seat. So they would always, if somebody has experience or if they know somebody personally who has worked at their company, then they might give him a little bit more privilege than a person who does not have any experience and who has not worked for them. So yeah,
Okay.
that's important.
So do you have any book recommendations for someone like wants to get started in machine learning and is a machine learning practitioner? Like, would you recommend certain books, textbooks?
I think the one of the books that I read and I liked is like the deep learning book. I think it's the deep learning book by
By
Ian
Ian Goodfellow.
Goodfellow.
Okay.
Yeah, I think it's a pretty nice book. It's a little bit complex at some
Yeah.
points, I think, but I mean, yeah, I mean, if I want to like learn a little bit about the linear algebra or the probability theory, then I would just go back to that book because it gives you what you need to know. It doesn't
That is
give
a
you
good
like a
summary
whole,
initially.
yeah, good summary. Exactly.
Yeah.
So that is one of the nice books. I think
Okay.
apart from that, I don't really read books as much as I read blogs, because I
Okay.
think you can find quite a lot of information in blogs or in research paper. Like if you Google, then you always land on blogs or you always land off research papers, and then you can get more information out of them. But the deep learning book is a nice book, I think.
Okay. So this will be the last question from my side, and then we'll open it all for the audience. Like, so what are your future plans if you are comfortable in sharing it? Like, what do you plan on in
Yes,
doing in future?
I don't know, like I'm kind of like at a phase. I mean, after I got a job, I think I got a little bit more interested in the area of the sensors. So I think I might spend a little bit time in like, yeah, developing products. Like right now, I work with the stereoscopic cameras, so I really like them, and so that's why I'm getting a little bit. I think I'm getting a little bit attracted towards the hardware side, so I might spend a little
Okay.
bit time on that. And yeah, then I think like after a year or something, I might look for better companies out there. Maybe if they want to hire me, then it's my future plan. Not that much elaborate, but yeah, let's see
Yeah,
how
it's
it
fine.
goes. But yeah, mostly it's like, yeah, I will be working in the field of, I think, machine learning, or I think like IoT based machine learning or stuff like that in then for the next couple of years.
All right. So I guess we'll open it up for the audience.
Okay, there are quite a lot of questions. I
Yeah.
know they're not that much. So let's take the highest voted one.
I'll
most like.
I'll dictate it out to them. Yeah, I guess Sarah will also share it on the screen. So can non-computer
Okay,
science
great.
into AI field? I think you've already
Yeah,
answered
sure. Yeah, sure. It's there is quite a lot of. Let me just like reiterate. There is quite a lot of information online. If you and I shared like the deep learning AI course is pretty nice, even if you don't have any kind of programming background. Then if you know like one programming language and if you have some kind of idea about the math, then you can surely go into the AI field. There is nobody stopping you.
I completely wasted my first year and I'm not in CS branch. Can I still go in the field of ML and AI?
Unfortunately, I think the first year in Jamia is a waste, even if you don't waste it. But I don't know.
Okay.
At my point of time, I was doing, I don't know what kind of stuff. I was doing drilling and all of that kind of stuff, which I didn't use, to be honest.
Okay.
But yeah, I mean, even if you think that you wasted your first year and you're not in the field of CS, still I think, I mean, you still have time. You can easily get your basics right in your second year. You can work upon the basics, you can work upon a little bit of the math, and you can do some like a couple of those courses. And then from the third year you can build up projects on that, and maybe in the fourth year you could do your thesis or something like that. Or maybe by the end of your third year you could do some kind of internship into this particular field. I mean, if you are not in a CS branch, then maybe try to find out projects in your own branch that could be solved with the help of machine learning and AI. If you're not able to find, then try to find some projects like generic projects that you can find, generic data sets that you can find online, so that you can turn them into projects. So I mean, it's not a problem. It's first year is okay.
Okay. So how did you apply to TU Munich? I guess that's the next question. And what requirements did they have?
So the TUM, yeah, I think unfortunately, I think it has been the case. Most of the people who have tried applying to TUM after I got, I think like after the 2018 batch, I think it was even of, I think in 2019, starting 2019. So the Bavarian government, like the state where Munich is, they changed something. And that's why the mathematic, like the requirements for the math has been changed for the university, at least for the informatics or basically the master's in computer science course. So I think mostly people find it a little bit difficult because they reject you saying that you don't have complete mathematical requirements for the informatics course or the computer science course. I don't know, like maybe you can talk to them that you already have students there. I think people have tried talking to them that you already have like our seniors here, then they also have the same course or something like that. But if you cannot go for a like a generic CS program, then you can go for like other type of CS program. So there is other, for example, there is one computational science and engineering, which is kind of like computer science, but it's a little bit more numerical methods and stuff like that. There is also data engineering and analytics, which where you need to do a couple of data engineering courses, but then you can take up all of the informatics courses. So yeah, I mean, about requirements, I think like they pretty much change quite a lot, and they also depend on the university to university. So the first thing that you should do is take a look at the website and what kind of stuff they are asking for. And yeah, if you have any other problems, then you can reach out to me so I can like help you out. But please reach out to me with like specific questions. I sometimes get questions, for example, I want to go into TU Munich, can you help me? Obviously I can help you, but what do you need help with? So
Yeah.
yeah, I think like that would be nice.
Okay. So the next question. Hi, I have done 3 month internship on ML and I have keen interest in ML, computer vision, and character recognition. After internship, I want to know what should I do to get a job.
Hmm. So first of all, I mean, you should have some basic understanding, as I said, like of data structures and algorithms. Try to do some questions in that area because they will be asked you in the first round of the interview. Like if you have a programming round in the company, then they would definitely ask you data structures and algorithms. They wouldn't ask you machine learning questions. Machine learning questions, they are basically I think they come up in the interview round. It depends. I mean, like if it's a startup, then they might not have this kind of round and they might directly go to an interview or something like that. But always, for the sake of security, you should do some DS algo questions, some popular DS algo questions that could help you clear the interview. And after that, you should create your resume, put your projects in the resume, put also this internship, what you did in this internship. and then just hope that you land an interview. I mean, it's not that much of a what you call a different procedure than a normal software engineering. I think like I don't know like how much of a support the placement office could provide you, since they only have like software engineering roles. I think companies for software engineering roles coming up, but you can always reach out to your alumni. For example, you have people in like Amazon. You have, I think like there are alumni. I have friends who are in really nice places, and I think they wouldn't like yeah, I mean, you have people in Jamia, people who are doing like in Facebook. I think, yeah, you have people in Google and everywhere. I think you have people in Pathia and something like that. So yeah, it wouldn't be a problem.
So a referral from
So
them
yeah,
is a possibility.
yeah, try to like get in contact with them. Tell,
Okay.
if you don't find a company, then try to get in contact with them. Okay, I have done this, send your resume, and then
Okay.
send that, can you please refer to me, and send a position also. Like, I found this position on the company, I see that you are in this company, can you please refer me to a position, here is my resume, blah blah blah, and thank you very much. So I think like they would be really happy to reply. I think they should be.
Okay. So let's on to the next question. Can you discuss the difference between ML and data science? That's a good one.
Yeah, I mean, like the ML and data science. I mean, in general, data science is basically the part that comes before the modeling, I would rather say. I mean, it's the parts that comes before and after the modeling. So you have the data. Normally, the data that you get, for example, if you get a data from sensor, or if you get a data from some other kind of resource, then it's not really clean. So what you do is that you first of all clean that data, so that becomes the data preparation step. And then you try to analyze data and get some insights from the data. And let's say that you get some insights of the from the data from a sensor about how many people are passing through a street or something like that. And you are not basically modeling that, modeling like not creating mathematical models, but you are just taking a look at the data and trying to get some kind of insights. Then all of this procedure could come up inside of the data science. So it's more like manipulating the data, trying to find patterns, interesting patterns in the data. And what you can, in machine learning, what you do is that you focus on developing those models specifically. And the models, you focus on developing the mathematical representations or the software representations of the models. You develop the infrastructure around the model. For example, what kind of how the model should interact with the data and all of this kind of stuff. So machine learning basically focuses on that. Machine learning in general, if you combine also deep learning in that, then it's more focused upon development of the data or development of the model. And data science is generally like playing around with the data to get some kind
Okay.
of insights. And then they kind of like interrelate with one another. So we have data science team, which would basically take the data and then play around with that. And they would say, okay, we have this problem and we would like to have a model for this problem. And then they would send the requirements to a machine learning team, and they would create a model and they would send it back to the data science team. They would use that model somehow. And yeah, then you would have some kind of insights in the company.
Okay. So the next question: best resource for machine learning. A very
Best resource
broad
for
question.
machine learning is the internet.
Yeah, it's a very broad question.
It's
Yeah.
a very broad question, but you can find quite a lot of stuff in the internet. And as I said, like deeplearning.ai is a really nice resource. And you can also find other kind of resources, like just try to Google it. I think it should be.
Do you have any comments on the Fast AI course? The Fast.ai course, which will
Fast
be
AI
top.
course is really Fast AI course is really nice. I think like the API, Fast AI API is really strong.
Mhm.
And I mean, I haven't tried using it. I'm because mostly like in mostly like when I used to do development of these machine learning or deep learning models, I would just use PyTorch directly. I wouldn't use any
Okay.
more high level APIs. But I think like if you really want to get quickly develop models or quickly do some experiments, quickly set up some baselines, then I think Fast AI API is really nice for that. So that's really nice. I think if you know it, then it's not a problem. I think it's an additional tool in your
So
pocket.
you learned PyTorch. You had to learn PyTorch separately because the deep learning.ai is in TensorFlow, right?
Yeah. I learned PyTorch because they use PyTorch at the university. They used to
Okay.
use that. Now they are using, I think, PyTorch Lightning.
So you prefer PyTorch or TensorFlow today?
I prefer PyTorch because I use that mostly.
So like
But
you
I
don't have
think
any
like
comments which is better.
I don't know. Like I think I've grown so much accustomed to PyTorch that
Okay.
TensorFlow, I tried using it, but I was like, okay, it's the same. Now they made it at the same as PyTorch. then
Yeah,
why
it's
don't I
very
use
similar.
PyTorch at all? And PyTorch also has really nice community around it, so I think it makes a little bit easier if you have. And TensorFlow, one of the most biggest problem with TensorFlow is that, okay, I have some projects that are there in TensorFlow 1.x, and then I now need to port them to 2.0. And that's not the case, that much of a strong case with PyTorch. So that's why I try to prefer PyTorch.
Okay. So what are the prerequisites? I think you've covered this. And what are the programming languages and other skills should we already have a hold of? I think we've covered
Well,
this one.
programming languages, like any one programming language, I think like if you know Python, then it's good because it has got such a good support, good
Mhm.
open source support. And other skills, I think like if you know how to write classes or something like that, then it's going to be really helpful for you.
So
Some sort
object-oriented
of,
programming.
yeah, some sort of object-oriented paradigm knowledge. I think it would be
All
really
right.
nice.
So is research paper necessary for doing MS abroad? So did you had a
Uh, I,
application when you applied for
no, no, I don't. I don't. I'm really bad at writing research papers. Really
so
bad.
so you don't have
I like
so
reading research, but I can't
okay,
write research papers. But
okay.
I think it's not necessary. But it depends. Like as I think like the competition has been increasing in the past, and most people are now getting research papers published.
Mhm.
So it doesn't hurt if you have research papers.
Okay. So is engineering mathematics, which we learn in first year, is a must for starting ML?
Not a must, but I think like I don't know. I completely forget engineering mathematics as soon as as soon as I give the exam, or as soon I get
Yeah.
my notebook torn apart. I would like done with I would like done with the stuff. So I think like but there are quite a lot of principles in engineering mathematics that are relevant for ML. I'm not saying use that book to read
Mhm.
about the math, but what I said that is that that kind of knowledge you should have. So I think you can find other sources for that.
Yeah,
You can
it's
find
much more.
other online sources. There is a really nice, I think like there is a really nice course from MIT that targets linear algebra
Yeah,
by
Gilbert
Gilbert
Strang.
Strang. I mean, I think like Gilbert Strang is a little bit too old to teach, so it's a little bit difficult
There's a
to watch
2006
him.
lecture. I think
Yeah. It's
that is
really
much
old.
more.
It's really old.
Yeah,
But it's really nice. It's really nice. If you want
yeah.
to do a little bit of linear algebra, do that. Otherwise, you can just find like Khan Academy is a really nice source for doing linear algebra. You can find like all of those matrix multiplication and what other kind of stuff on that.
Okay. So, what are the differences between a data engineer, an ML engineer, and data analyst? The
Oh,
three
I feel like I'm giving an interview. They also ask these questions in the interview.
Okay.
Data engineer, ML engineer, and data analyst. So the data part is kind of like you work exclusively with the data, and the machine learning part, I would rather say you work with machine learning models. So the data engineer, what we would do is that he would work with databases on how to get the data inside a machine learning model, developing APIs or just setting up the infrastructure for the data. For the data analyst, what he would do is that I think they work really closely with data engineer. Even they would do some stuff for the data engineer. Is that when you have got a data, then you want to like make some analysis on that, just like the data science team. You want to do some, for example, you want to clean up the data and find out like the interesting parts, interesting features of the data that might be useful for the machine learning model. And this is something that data analysis might do. For a machine learning engineer, you will focus upon developing algorithms, developing the infrastructure around algorithms, making sure that the algorithms is working fine, it's training fine, it's logging fine, and maintaining it after it has been deployed or something like that.
Okay. So, can a student pursue both web development, so generally development and ML AI during BTech?
Yeah, no, I mean, it depends. I think you can do that. Uh, uh, yeah, I think you can do that, but I think it's a good idea to focus yourself into one of the domains, because I think like they are pretty much heavy domains. So I mean, you can do that. For example, you do like web development 1 year of your college, and then the next year you could do machine learning or AI. It's not a problem. But then obviously it would be less effort than if you spend 2 years in ML or AI or something like that. So yeah, there is a trade-off.
So, the professors that we can approach for letters of recommendation, professors at
I
Jamia.
mean, professors at the CS department.
I guess I'm not sure about who. What is the
I
branch?
mean,
Like,
like I know about just the CS department. So there is Professor Tanveer, and he was the HOD when I was there. He's really helpful. I mean, I think like he's really helpful, and he helped me quite a lot, like in getting the LORs. Then there is Professor Bashir. I got one LOR from him, and then you can get it from like Professor Sarfaraz. I think he also doesn't have any problems with giving out LORs. But I think Professor Tanveer, I mean, I think he gives out LORs to people quite a lot, so it's not a problem. So you could
okay,
approach them, Professor Bashir, Professor Tanveer. I forgot one of the professor's name. I don't know. Professor Zishan also gives out LORs, so you can even ask him. I mean, normally nobody would like turn you down for an LOR, but I think it would be nice to get an LOR from a professor, like
hmm,
not from
okay,
an assistant professor or something like that, because if they have like a professor title, then it's a little bit more heavy.
okay. So, is strong DSA important for ML and data science job?
I
Yeah.
mean, they are important for interviews. So,
Hmm.
I mean, and yeah, if you are getting a job, then you need to clear the interviews. So that's why.
Okay. So, when did you start this ML journey? In which semester? Like specifically which
I think
semester?
second semester I started this. I think not second semester. I mean, sorry, second year. So I think it was
Okay.
either third or the fourth
Third.
semester.
Okay. So, which is more future proof, ML AI or
Future
development?
proof. I mean,
Like,
if you want to
whose
get
job is more
just a
future?
job, I mean, if you want to get like a job, then development always has jobs. I see so many
Okay.
jobs for backend and front end developer. If you just focus on the job, I want a job, and then you can do React and Node. I think React and Node.js, then you will definitely find a job. MLAI is more like, I think it would be a little bit difficult to find a job in MLAI, I feel. Normally,
Okay.
because it's such a nuanced, I mean, it's such a, I mean, it's such a field that is still in the development phase. So you can find quite a lot of jobs, but you can also find like yeah, maybe some competition around that, or maybe the jobs might explicitly require you to have a PhD. I mean, in Germany, I find quite a lot of jobs that say, okay, we need a PhD, so you can't really do anything about that.
All right. So, I guess there's a last question. How do we start with machine learning in third year? Like, if
Third
what would
year, I think
advice?
just do a course and start building projects. That's the simplest thing that you could do. If you already know a programming language, just do a course so that you can get the basics. And as soon as you get the basics, try to do some projects, use Kaggle, maybe something like that, so that by the end of third year, you can build up projects by yourself for a machine learning. For example, if I give you just a data set and tell you that this is a problem, then you can, yeah, find sources online, and then you can build up a solution for that. So this is something that you should aim for. I think it's possible to do that in a year.
All right.
And
I
from
think
fourth year, you can just start off with your again major or minor project or something like that.
so. I think that concludes all of the questions from the audience. Now, I would like to, for the people who have gotten excited to pursue machine learning, I would like to introduce our the IEEE Computer Society machine learning team has created a machine learning camp. Uh, Let me just find the link. So the machine learning camp is going to be held from today, where we would send out a WhatsApp group link on the community, and the the whole philosophy of the camp is that the as a community we could be able to learn a lot more, and there's a lot of you can be a lot more motivated when you see everyone is learning together and everyone gets started. So if you don't have any idea about Python, any idea about machine learning, you can join this camp. You're very much welcome. You'll have objectives to complete as part of the camp. These objectives will be Kaggle certificates, so you'll have something actionable to work towards. So I would welcome you all. We have a lot of things planned as well in the machine learning camp. These are you will be introduced to Python. We'll share resources to learn Python, and then we'll also introduce you to the popular machine learning libraries inside of Python within the camp. And also, we have planned out to do reading sessions on the machine learning textbook, the hands-on machine learning with TensorFlow, Keras, and with scikit-learn, Keras, and TensorFlow. So, if you are interested, so please do join the camp. We'll send out the invite link to it. Now, I would hand over to Sarah to hopefully conclude the session.
Great. Thank you, everyone. We appreciate you being here. Do fill the feedback form sent in the chat box. Now I would like to call Faizan Chaudhary, Secretary of our society, to give vote of thanks to our guest.
Thank you, Sarah and Abbas. I would like to extend my heartfelt gratitude to Najeeb Bhai for taking out time from his busy schedule to help guide the students. I am sure that everyone who has attended the session will obviously get motivated towards this emerging field and will find the roadmap given by you to be of great use. It was a great honor having you here, and we would be glad to interact with you to learn more about ML and AI in the near future.
Thank you very much for that.
Also, I'm
And
grateful.
thank you everyone.
Yeah. Also, I'm grateful to all of the participants for making this session a huge success. We have more sessions coming up in line in Break into AI, as discussed by Abbas, where you'll all be guided. So be sure to avail their benefits. Thank you all for being with us till the end, and make sure you provide us with your valuable feedback. Thank you and have a great weekend.
Thanks a lot,
Yeah,
everyone.
thank you everyone. Thank you Abbas, thank you Sarah, thank you Faizan. And yeah, good luck. I think yeah, it would be nice if you join this session. See you
Yeah.
guys. Bye.
Bye, everyone.